So you're welcome back to class with Ada. Thank you for subscribing to my channel. Please keep doing that. Share with friends, share with family members, share with cousins, share with anybody you know that these videos will be of help to. Thank you. If you want to reach me via this contact 0816486940. Yes, this number, you can reach me on WhatsApp with it, you can reach me on Telegram with it, and you can reach me by call. Thank you very much. Quickly, we'll continue with our work from where we stopped in the previous video. Now we were talking about we'll be considering we're talking about plane shapes. So we talk about a triangle now. A triangle. Triangle can be in different forms. You have this is a triangle. I do this. This means two sides are equal. This is an isosceles triangle. If I draw this, I do this. This is an equilateral triangle. But if I decide to do this, I do this, this shows is a right angle here. So I have right angle triangle. Here, this is the height here. This is the base here. This one, if you want to get the height, you can decide to bisect this angle and bringing this down, and this will give you your height. This one too is allowed here too. If you do that here, it's allowed. There's another type of triangle I've not drawn. If you have something like this, let me call this A, I call this B, and I call this side C. So this is a scaling triangle. None of the sides are equal. They are not told, not two sides are equal. Now quickly know this, for the isosceles triangle, if these two sides are equal, automatically their base angles will be equal. So you have A here, you have B here. So your A will be equal to your B. Sorry about that. So A will be for this. And for the equilateral triangle like G here, this angle is equal. They are all equal. So that will be 60. So if you have 2 here, I have 2 here, this one too will be 2. I mean in meter or centimeter or millimeters or any other units that you are measuring with. So this angle, now for this isosceles, this angle will be different. It's only the base angles that will be equal. This one, for this scaling, it will be totally different angles. None of the angles will be equal to each other. So here, this one you have this, then you have this. Are you seeing that? So this is a scaling triangle, this is a right angle triangle, this is an equilateral triangle, and this is an isosceles triangle. Now if you have this type of triangle, right angle triangle, okay, somebody will call this left angle triangle. It is still the same thing as the right angle triangle. This is having a height. Don't let me, I want to write a value so that we work with it. So let me use this. Let me say this is 6 meters and this one is 4 meters. It is not drawn to scale, so don't crucify me. So you have your A, your area. Area will be equal to 1 over 2 times the base, then times the height, and that is equal to what? 1 over 2 times, what's the base? The base is 4, then times the height, which is 6. So if you like, make them over 1. So 2 cut this, 2 here 1, 2 here 2. 2. So the answer becomes 2 times 6, and that is 12 meters squared. So you have 12 meters squared. That's the area of that. If you were to calculate the perimeter, all you have to do is add the 3 given sides together. Now, there's something I expect you have observed. Is when I spoke of the parallelogram, I gave the formula to be base times height. I gave the formula to be base times height. So if you are having something like this as the parallelogram, what do we have here? If you observe that if you divide this parallelogram into 2, you have 2 triangles. This triangle A, this triangle B. Yes or no? So that is why the area of the triangle is half of the area of a parallelogram, which is half base times height. Area of parallelogram is base times height, then area of triangle is half base times height. It is half of it. So that is that about that. Let's talk about another shape. Yeah, I will tell you the area you use if you are calculating. Let me just quickly mention that if you are given, okay, we'll talk about that in the next video. Yes, let me quickly mention something here. If you are having to if you have to deal with let's wipe this. Let's talk about the trapezium. The trapezium. You have the trapezium. How do you go? So in another video, I'll be talking about how you can calculate the area of different triangles. We have that if you have a triangle that is like as an isosceles triangle, or an angle such that a triangle such that you are given only 2 sides. How do you go? Or you have a triangle like the scalene, you are given only the 3 sides, no angle given. Heron's formula. So we mentioned that in another video. So quickly, if you have this, I want to write the trapezium. So you have the trapezium to work with. How do you go? You have this, another person can decide to even make it load this way too. So you have this, as the height. This is the height here. I can label it A, B, C, you have D. So what do we have? Now, a pair of opposite sides are parallel, just a pair. Only these 2 sides are parallel. Only these 2 opposite sides are parallel, but they are not equal. And this AD is not parallel to BC, no. And a pair of angles are also equal. This angle is equal to this angle. Yes. So another thing again, that's no line of symmetry. So if you're talking about the area now, the area is, you have 1 over 2. Please let me permit me to label AB. Okay, half of, you have AB plus DC, close the brackets, then times height. This is the height. So your perimeter, of course, I don't need to write that. Addition of all the given sides will give you the perimeter of the shape. So if you are giving something like this, let me say the dimension you are giving, this one to be 4 centimeter, and this one is like 8 centimeter. And you are told to calculate the area. What do? You go 1 upon 2. I said AB, open brackets, our AB is 4, plus DC, which is 8, close the brackets, then times height. Oh, I must have been given the particular height. The height, let me name the height to be 2. The height is 2 centimeters. So that will be times 2. What do I have? This 2 can cancel because this 2. So my answer becomes what? 12 centimeters square. So it is as simple and direct as that. Thank you for stopping by. I've done something on circle. Yes. Okay, let's start circle. One of my video, I should have done something on circle. So to have this, that's trapezium. Then quickly let me come to circle. If you have this, you are given this, you can draw this out. If you have a circle, you have this, you have something like this as a circle. Let's manage my circle. So if you have this, let's say from the center, the whole part of this circle is known as circumference. So any line that is drawn from the center of this to the circumference, either to this point or to this point, or from here to this point, to any line drawn from the center of the circle to any part of the circumference, it is known as the radius, irrespective of any side of the circumference is drawn to. But if you're having a line cutting the whole circle into 2 equal halves, a line that cut the circle into 2 equal halves, it is known as diameter. It is known as what? Diameter. Okay, let me indicate with another one. We have this, and this is drawn. Let me say this is drawn to cut the circle. It must cut the circle into 2 equal halves before you can call it a diameter. This is diameter. And the radius is equal to your diameter over 2. Radius is half of diameter. But if you have a line drawn somewhere here, of course we know this is not the diameter. This is what we call a chord. This is a chord. But if you have this side shaded, this is what we call is a segment, and it is a minor segment. These are some of the properties of a circle that everyone and anyone should know. Minor segment. But if you have all these sides shaded, let me use another marker to shade this side. I have this side shaded. You can see that the larger parts of the remaining large part of the circle, the remaining part of the circle is larger. So this is known as the what? It is known as the major segment. It is major segment. Major segment. Now, the other properties of the circle. If I have a circle and I have something like this, and this is drawn, let me use this. I have something like this, drawn like this, the whole of this is called, and an angle is subtended at this point. The whole of, if you draw it out, you have something like this. This is a circle. This is a circle. So we have other things that we can talk about there, but these are the main properties you should know in a circle. So the area of a circle is known as pi r squared. This is a pi, and the pi is a constant. The pi it is known as 20, is a constant given as 22 upon 7, which is equivalent, or if you change to decimal, you have it as 3.142. But the circumference of a circle, CIR, the circumference, I will write that in full, circumference is equal to 2 pi, circumference of the circle is 2 pi r. That is when you differentiate the area, you get the circumference. So 2 pi r, it means distance along or around the circle is 2 pi r. So it is as straightforward and simple as you can see. So thank you for your time. We'll see you in subsequent class. Thank you, thank you, thank you.